We will know how fast I am.
Cycle is fast.
Anyways, cycling is the best. Right, let's continue.
Where is Go?
Where is Go today? That's right.
There is Go.
Newton?
What?
Yeah.
Oh yeah.
Newton was very smart.
Yeah.
He did many things.
Yeah, I know.
Come on, Summer. Ready to start?
Yeah.
Okay.
This.
Mm-hmm. So, here's the problem. Suppose, for example, I have a cubic equation.
Which page? Sorry.
Have you got it?
Yeah, got it.
Yeah. Yeah, your book's the same as mine. Okay, so, question. Let's say I want to find the roots here. What do I do? Well, what did you do in semester 1?
What?
How did you find the roots in semester 1? Like, suppose you want to find one of the roots, what do you do?
When the y is 0.
Yeah. So how do you solve this? Do you remember what you did in semester 1?
Yes. Y equals 0, so fx equals 0.
Yeah, so what's x?
And slow it.
Yeah, but how?
How?
Yeah. How? If I said like x cubed plus x squared minus x minus, no, not derivative.
Try.
Try and guess.
Yeah.
What?
So what you do is you try f0, then f1, then f minus 1, etc. Now what's the problem with this? Well, it doesn't work if your roots...
Yeah, I think it's very stupid. Yeah.
Yes. So, we need a better way. And that's what we'll learn today. It's Newton-Raphson. Okay, so, here's the idea. There's x, there's y, and let's say, I don't know, there's some curve like this. Okay, this is y equals fx. So let's imagine you guess a root, okay? So your first guess is x0. So we'll call this our first guess. Now, are we right? No, because this is the right answer. So we're too big. Okay, maybe for example this is 2.1 and we guessed 5. We're too big, okay? But this is what you could do. You could draw a line up here and then you could get a tangent this is a tangent, and then this point here, well, that would be better, wouldn't it? That's closer to the true answer than this is. So let's try and figure out what that point is. Well, this point here is the point x0, fx0.
Yes.
What's its slope, though?
It's dy dx.
Yeah, like that. So using the formula y minus y1 equals m times x minus x1. Yeah? Yeah. Now, this point here is the root. And we'll call it x1. And we need to make y0 to find this point. So we have 0 minus fx0 equals f derivative x0, x1 minus x0. So you can get x0 minus fx0 over f derivative x0, that's equal to x1. In other words, if you guess x0, then this formula gives you a better guess than the one you used. So you can start at x0 and move to x1. But then you realise, well, hang on, I could just do this again. And I could get an x2, which would be x1 minus fx1 over f derivative x1.
But it's like the dy dx.
Yeah?
It's got smaller.
Well, yeah, that's it, yeah. Exactly. You move into the answer.
Yeah.
So you have this formula called Newton-Raphson Formula, which says x n plus 1 equals xn minus fxn over f derivative xn. This is the Newton-Raphson formula. Now, I'll give you an example of how to use it now in a minute, once you have what you need written down. Yeah, sorry, that's an X in there.
Why the first
Yeah.
step? Why the first step? You y minus fx0.
I'm using this.
Oh, x.
Oh, sorry. I'm using this formula. Y minus y1 equals m times. Oh, sorry.
It's
I made a little mistake, didn't I? X minus x1.
yeah.
So I should have had here, thank you Summer for spotting that, y minus y1 equals, I should have brackets here, shouldn't I?
Yeah.
Yeah. But when you rearrange this, you do get this. I just forgot my brackets there.
I'm sorry. Tired.
Oh yeah, it's terrible.
Tired.
Me tired, yeah. I stay up too late. It's my fault. I should go to bed sooner.
When?
Last night?
Yeah.
Oh, terrible. 2 a.m.
2 a.m.
2 a.m.
I go to bed 3 a.m. I think. I need to do my chemistry report.
Oh dear.
I 10.
You're 10 p.m.
Yes.
Oh.
You're the only good student here. You're the only good person here going to bed early. What time do you go to bed at? Yeah.
5.
You're the only good one, Ben.
5 a.m.
Yeah.
Oh my god.
Yeah, not 5 p.m. because he's still in school.
If keep going on, we will lose all the hair.
Yeah, we need to be careful.
Yeah.
Oh, I just tired. I write lab report.
We'll talk about the physics lab report this week too, maybe.
What?
Don't worry.
In our voice.
Oh, Summer.
Oh.
I was looking at your plan,
Yeah.
your physics plan
Yeah.
that you sent me.
Yeah.
It's terrible.
Yeah. I know. I know. I forgot to write the.
You forgot to write like everything.
No.
You wrote a little bit.
I just forgot to write the fourth step. I think.
Yeah.
But the others, I had.
They weren't great.
What?
It wasn't great.
Okay, I will fix.
The English is not so great.
I will fix them.
Okay. Anyway, so continue. So let's have a look at an example, okay? Now we'll pick an easy example to get the idea. So suppose I want the root of x squared minus 2. That is, I want to solve this. Now this is a good one, because we already know what the answer is. What should be the answer here? 1 point is about 1.4141 roughly.
Oh yeah.
Okay. Now, let's pretend. Actually, I know what I'll do. There.
Also minus.
Right. Yeah, plus or minus. Let's pretend we don't know the answer. We don't know the answer. Let's just write down this. 2x. Okay. So xn plus 1 equals xn minus fxn over derivative. Okay? Let's test this formula out. So let's make a guess at what the answer is. And let's make a really, really bad guess. Let's think the answer is maybe
0.
No. Really bad guess. We'll say 1,000. No, we'll say 1,000,000. We think the answer is 1,000,000. Is that a good guess or a bad guess? That's a really bad guess. Let's see what Newton says a better guess would be. So, if I get out the calculator, let me calculate this. Okay. X minus xn x squared, sorry, minus 2 over 2 times the answer. Now answer here is saved as 1,000,000.
Yeah.
So if I press equals, I should get a new answer. I get, what's that, 500,000. Okay. So if I put in 1,000,000, I get back 500,000. Right, let me put in 500,000 into this formula and see what I get next. I get 250,000, okay. Let's see what happens next. I put that in, let's see what I get next. Okay. Looking good. We're getting quickly to the answer.
No.
Okay. No, well, let's see. That's number 4. Okay, that's number 4.
Yeah.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, looking good. 24, 25. There you go. So after 25, I got to root 2.
Yeah.
Now, you might say, well, that's a lot. No, it's not, because I started at 1,000,000. Now think about it. If you started guessing at 1,000,000, you would have 1,000,000, and then you would try 999,999.
Oh.
You know, if you had to guess one by one,
Oh.
how many would you get? 1,000,000. And would you get the right answer?
Yes.
Well, no, actually you wouldn't, because what would happen is, first you try 2, then you try 1, and then you're like, oh, I went too far, and you have to go back. And then try the middle, yeah. But I only needed 25 steps. Now suppose I started nearer the answer to begin with. So suppose I started with, like, I imagine maybe I start at 5. Let's see how quickly I get from 5. Okay, so that's 1. 2. See what it looks like. Okay, looks good. 3. 4. 5. 6. That's it. 6. Okay. Now, actually, in the exam, they usually want you to stop after 2 decimal places. So let's go back to 5 and see when we could stop. So I start at 5. Let's go back. Okay, that's x1. Are we right? No. Still more to go. x2? No. x3? No. x4 done. I've correct now to 2 decimal places after 4. Okay, this is Newton-Raphson. So you see, it's a very nice method.
But how did we know?
How to know where to start? Good. So that will be the next thing. So let's take, let's do a full example. Oh, before I do, some advantages and disadvantages. Okay. So I'll try and leave that there for you, Ben, because I know you want to write that down. So advantage. It's easy to calculate. Right? What else is good about it? It's fast. Yeah? Disadvantage. Number 1. It can only give you one answer.
Oh, yes.
That's a disadvantage. And number 2, we have a problem if this happens. There's a problem. I can draw it in a picture. Okay, so imagine I start here and I draw a tangent. Where does the tangent cross the x-axis? It doesn't.
Yeah.
That's because in the formula, you see, you can't divide by 0. You have a problem there if this is equal to 0. It can't be equal to 0. So this is a disadvantage. Okay. So sometimes what happens with these problems, if you see here, look, see this guy?
Yeah.
Here's the root. Let's say I start here, okay? Watch. Draw a tangent, go up. Here. Draw a tangent, go up. Here. Draw a tangent, go up here. See what's happened? I'm stuck. I got stuck in a loop here. I can't break out. This is the problem with Newton-Raphson, potential problem. Let's have a look at a cubic example though. Can I scroll down? Okay, so let me see. I just want to take, yeah, we'll take this one here. So suppose I ask you to solve this. Now, the first thing you need to do is make sure that you have a root. And in the exam, they will say, usually part 1, prove there is a root. Okay?
Okay.
This is quite easy to do, actually. If you can show that for A, you get a positive answer, and for some number B, you get a negative answer, then you know in between there must be a root. Okay? So let's see. Let's just pick a number. Let's just say x is 0. So f of 0 is equal to minus 18, which is 0.
Yeah.
Right, now we want to try and make this positive, so I think I should pick a negative x, like minus 10. Because that would be minus 4 zeros, 10,000. Yeah? Plus minus here. Oh, sorry. So I'll use a plus 10.
Yeah.
Okay. Plus 300 plus 370 minus 18. Oh,
Minus.
that's a negative. Right, okay. I don't want that.
It's minus 10.
I should have done minus 10. Right, let's do minus 10. That's 10,000 plus 300 minus 370 minus 18. Okay, that's positive.
Yeah.
So, since f changes sign between minus 10 and 0, that means there's a root somewhere between minus 10 and 0 because it changes sign.
So can I don't write the things
No, because in the exam this question is 3 marks and you get 1 mark, 1 mark, 1 mark. Yes, it's true.
In my high school, I usually forget to write this in Chinese, so I lost a lot of marks. I feel tired. Between two changing sign between
Minus 10 and 0. Okay? Now, there is a second way to do this, or you could try to graph it roughly. So this is, first you try to find the stationary points, the turning points. F derivative x is minus 30x squared plus 9x plus 37 equals 0.
6x.
Thank you. 6x plus 37 equals 0.
Yeah.
Does this have solutions? Let's see.
Oh,
Yeah, I know. 1.2 and minus, okay. 1.2 or minus 1.01. Okay. So, very quick sketch. There's 1.2. There's minus 1.01. That's x, that's y. Now, if you sub 1.2 into this, and sub minus 1.01 into this, well, no, actually, hang on. What we could do is calculate the second derivative. What's that? Minus 60x plus 6. So this one here, second derivative of 1.2, would be negative. So that makes this one a max. And this one here, a min. Okay. And if we put minus 1 into this, what do we get? Roughly minus 10 plus 3 minus 7, 30, 12, roughly 12. So this point would be up here. Okay? So this point, it must be like, I need a calculator. Sorry.
is also 12, I think.
Is it?
Yeah.
No.
Nearly 12.
A little bigger. Okay, fine, whatever. So it's up here. Okay. So if you draw this, this is a min. Look. This is a min. And this is a max. Now, because this is a max, it means it must be coming down here. So therefore, there must be a root to the right of 1.2. There must be, because it's coming down here. So eventually it has to hit here. You got the idea? Okay. So let's just make a guess. We have, what the heck? No. Oh, sorry, that's a plus 10, wasn't it? Minus 10? No. My graph is ugly, it's wrong. I'll draw a nice graph. Terrible. Yeah, my graph is very wrong. Hang on, I'll just draw it on the program. Hang on, I'll just draw it here. Look, minus 10x cubed plus 3x squared plus 37x minus 18. So I have one answer on the right and one answer here. That's a max. That's a min. Oh, my min is negative. Minus 1. If I put in minus 1, I'm supposed to get a negative. Ben, could you, if we put minus 1 into this, what do we get? 10.
13 and
13.
It's not a minus.
But it's a minus here.
Wait.
Oh!
It's
That's minus.
yeah.
That's
It's
minus.
minus 1.
It's plus. Huh?
It's
Minus 2.
it's minus 1. If we put on
There's minus 1. It's negative. It's negative at minus 1.
minus 1 is 10.
Yeah.
And
So,
minus
minus 1.
1. What the? Oh, 37.
Minus 37. Ah, right. That's terrible. Right, it's down here. And this is still the min, and this is still the max. So it must be going like this. So we know that there's a root to the left of minus 1.01, or there's a root to the right of 1.2. Okay?
Yeah.
Now, if you look here, we know there's a root between 0 and minus 10. So that was this one here. 0 minus 10.
Yeah.
Okay? Which root will we try to find? Which root do you want to try and find?
Each root.
Yeah, which one first?
First,
Yeah, which root will we try and find first?
left.
Let's try and find this one, yeah. So roughly, have a guess, where do you think it would be? I think it should be around about here, at maybe about minus 2.
No.
Well,
Okay.
maybe not. Maybe it'd be at minus 3, maybe it'd be minus 4. I don't know.
I think
So
it's
look,
okay.
here we know that it's between 0 and minus 10. So I'll start at minus 5 and see where I end up. Okay, so let's use our formula. xn equals n plus 1 equals xn minus...
Oh, we can.
Yes, Ben?
I know.
And then the derivative, minus 30 xn squared plus 6xn plus 37.
Xn just answer.
Yeah,
Okay.
it's like a loop.
Yeah.
Right, so shall we try and see where we get with this one? Okay, where did we say we start? We said we start at 5. Okay.
Minus 5.
Thank you, minus 5. Okay, so we have answer minus fraction minus 10 x cubed plus 3 x squared. What's next? Plus 37 x minus 18 over minus 30 x squared plus 6 x plus 37. Okay, so here we are, minus 3.489.
Yeah.
If we start at minus 5, next we get to minus 3.4899. Okay? Next, minus 2.5, minus 2.14, 8. So after 8 of them, we end up at minus 2. So, minus 2 is an answer.
Yeah.
How do we get the other answer? We could do this, or we could just divide.
Oh. So
Yeah.
x square x square is
We don't have to divide now. I just want to say you can divide to get the next answer. Okay? Here's one for you. I'll give you one to try. You have to think about this. Here is the line y equals x, and here is the curve y equals ex. Okay? These meet at two places. The first place they meet is here. No, I'll try and draw that again. Y equals x. I think it goes like this, maybe. You know what? I'll draw it. Y equals e power x.
Why is so big?
Oh, they don't meet.
Yeah.
I'll have to change this a little bit. We'll say x minus 1. Maybe I'll get them to meet. Ooh, too close. X minus 2. Ah, nice. Right, so they meet at two places. I want you to find one of those at least. So the first one is y equals x, and the second one is y equals e power x minus 2. On the graph they look like this. They meet at two places. I want to know those two places. Okay? And my hint is to make the function fx equals, let's have a look here, x minus ex. Now if you think about that, you might be able to figure it out. What do you want for f? What do you want it to be? What number? Here. 0. Because if f is 0, then you know x equals ex. So you're trying to solve this and this. Does this make, can you see, if f is 0, then x must equal ex, which means you've solved these two. So my question is really just to solve this problem. And I'll tell you even where to start. This answer is near to 0, so you could start at 0. So start at x0 equals 0. And see if you can find this point here. Okay, go use your calculators. See if you can find it. You need your calculator for sure. Got your calculator, Ben? Calculator?
What is x? Just before. How to type x?
Ah, no. What you could do, just, like, you can just type it like this. So just use answer.
Oh.
So for example, you want to start at 0,
Yeah.
so you press 0 equals,
Yeah.
and then you can type it in. Answer minus.
Oh. Oh my god.
So I need you to tell me x1, x2, x3. You got x1?
Yeah.
What you get?
Minus 0.1.
Minus, okay. What's x2?
It's minus.
Minus again? No, I think you're doing something wrong here. Let me show you. Okay.
Is this one? I think
No, it's not. You made a mistake,
Okay.
I think. 0.
Yeah.
Put 0 equals.
Yeah.
So now if you type in answer, you get 0.
Yeah.
Okay? So answer minus bump 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 x minus e power x minus 2 over the derivative.
Oh.
Yeah, which is 1 minus e power x minus 2. That's the derivative.
Okay.
So x1 0.1565. x2 0.1586. x3 0.156. I'm going to just use this formula 3 times and 3 significant figures. 1, 2, 3. 159.
Yeah.
Now let's see how good my answer is. Let me ask the computer to solve it. So I'll say number 3 equals, no, x equals e power x minus 2, solve. .15859. I think that's actually what I had, isn't it? 0.15859. Oh! That's the exact answer. Well, that's it. I only needed it 3 times. The reason I only needed it 3 times was because I was so close to begin with. It's useful. You can use this to solve any problem, you know. Like you can see in number 10. Nice, huh? It's very nice. Yeah? I will ask you to do okay, so can you do 1b, 2b, 3b, 4b, 6, 8, and I know you want to do 10, 11. I give you a choice. You can choose 10 or 11. You don't need to do both. Do 10 or 11. Yeah?
Okay. So finished.
Well, we have 2 lessons now.
Yeah. So the next lesson is slowest questions.
No, the next lesson is something different. I'll let you try this for 5 minutes and then we'll do the next lesson.
Okay.
Don't worry, Summer. We'll finish at 340.
Yeah,
Okay, don't worry.
No, I think it's too difficult.
Next lesson is actually not too difficult.
Oh,
It just looks difficult.
okay. No, I said this.
Oh, that looks, yeah, well, that it is difficult. Question, Ben?